Okay, great. So we're going to get started so we don't float too much off schedule. My name is Kelly Blumenthal. Those of you who joined in as KB joined in as me, and I apologize for that. But thank you all for being here. So I am the Deputy Director of the Office for Astronomy Outreach at the International Astronomical Union. And I'm here today with some of my friends and colleagues from the Chandra X-Ray Observatory. And we're going to talk to you a bit about making astronomical images accessible to a broader audience. Just so you know, this workshop is a follow-up from another one that we held at the beginning of December on image processing, although you don't need any prior knowledge to come into this workshop and learn something. So don't worry about that. All right, so the JWST team described this image as a fiery hourglass. And in this nebula, the colors represent the thickness of the dust in the nebula, with the thinnest regions kind of at the bottom shown in blue, and the thickest regions shown in a deep red and orange at the top. The hourglass itself is carved out by the bipolar outflows from a young star that's embedded deep within an edge-on protoplanetary disk at the neck of the hourglass. And the images that are created by observatories, both on the ground and in space, are incredibly important for the communication of astronomy, both in science and for the public and public outreach. In the image processing workshop that we held at the beginning of December, I posed these questions to the audience. Why do we create these images, and what purpose do they serve? And the participants shared many things, but namely that these images can inspire awe and curiosity, but also that they contain a significant amount of scientific information. So I'm going to share with you some of the information that was discussed at our image processing workshop. Most of the slides that I'm going to share are from Madi Zamani's presentation, who talked with us about his process for creating images for the ESA web team. So if you're here, I'm not sure you're at this one, but at the next one, probably. Madi, thank you so much for presenting this information to us. All right, so once light takes its very long journey through the universe to us, it might pass through an instrument like MIRI on JWST. And you can see the light path reflecting its way through the instrument and then through a rotating wheel of filters, and then finally onto the detector at the back of the instrument. But it's important to remember that different wavelengths of light require different telescope designs and technology to observe them. In the case of the Chandra X-Ray Observatory, the X-ray photons have way too much energy to reflect through an instrument like MIRI. An analogy that I heard was that the X-ray photons would go through MIRI like bullets through a wall. And instead, the Chandra X-Ray Observatory has a very long tube that's filled with hyperbolic mirrors, off of which the X-ray photons kind of just graze and are eventually focused into an image at the back of the tube. And there's many steps between the light hitting the detector and actually producing a final color image. And I'm going to very quickly go through this process. So the raw data that you get from the detector itself might contain multiple exposures. Here we see a faint image of a galaxy formed from overlapping exposures of various size rectangles. But when stacked on top of each other, they produce a much clearer image. And you might decide to crop the image depending on the artifacts of the edges, or maybe just some artistic choice, and then adjust the levels of the background. Maybe you also adjust the noise and the bias as well to accentuate the features that you want the user to focus on. If you have multiple images from different filters, you would assign colors to each of these images and then combine them. One way to do this is by chromatic order. where the longer wavelength filters are colorized in red, and the shorter wavelength filters are colorized in blue. And the result, after maybe some touch-ups, is an image like this one. It's a swirling center of a galaxy with knots of star formation that spiral out along the web-like arms of this galaxy, which is Messier 74. And the result, of course, will depend on which telescope has observed it, and by extension, which wavelengths were observed. So combining images from multiple different telescopes like Hubble in the optical and JWST in infrared can produce new perspectives and understandings. But chromatic order isn't the only way we can colorize our images. In some data, we have access to three-dimensional information with the inclusion of velocities or redshifts. So in images like this one, which is a composite from Hubble, showing a field populated with galaxies, we can colorize the image based on how fast light is moving towards or away from us. And in particular, this particular image, the zoomed in region, shows emissions from doubly ionized oxygen that has been colorized blue for emission moving toward us and red for emission moving away from us. And this helps us understand a bit more about the three-dimensional structure of the object and the mechanisms behind the object that's producing this radiation. So I know that this is not new information for many of you, but there are a few key takeaways that I just want to point out. First, that these images contain scientific information. While they, of course, can be used to inspire us and to pique our curiosities, they also help us understand our universe better and place our research into context. Different colors can represent different things, including temperature and dimension. And it's also very important to recognize that color and composition can actually change the way you perceive the image that you're looking at. So maybe seemingly more artistic choices that you make could wind up really changing how people understand and conceive of the image itself. And then finally, I think we all recognize that there's an enormous amount of work that goes into creating images like this. We should really be very grateful for the image processing teams who make these images available to us and to the public. But the reason why we're gathered here today is because this is not the end of the story. We've come a long way in the art and science of image processing in astronomy, but we have a lot of learning to do when it comes to making these images accessible. And to give you a sense of what I mean, take a look at this example of an image caption from Astronomy magazine. And I chose this as just a random example. This is not to call out Astronomy magazine in any way, but it's very canonical, we might say, of captions that we see in popular science magazines today. But the caption reads, researchers used NASA's James Webb Space Telescope, or JWST, to capture new images of Saturn's moon Titan on November 4th, 2022. And just based on this information alone, it's kind of difficult to know what the image looks like, what it contains, and what it means. And for those of you who are sighted who are here, you might be surprised to see that this image caption, that this is the image that the caption referred to. There's actually two images of Titan, one right next to the other. On the left, the lower atmosphere clouds and haze that surround the moon are colorized by the thickness of the cover from dark red to white. And one extended high density region sits near the southern pole of the moon, representing haze in the atmosphere. At the top right and maybe a little bit on the top left near the polar regions is another more concentrated region of high density cover that is a cloud that's visible. And at the right, Titan looks kind of like a blue marble. It has seas of hydrocarbons and a surface of water ice that we can see pretty visibly through the atmosphere, even though usually when we think of Titan, we think of it as kind of a hazy orange world surrounding or orbiting Saturn. So clearly this is a rich image, deserving of an equally rich description. And with that, as a small teaser, I will hand it over to Kim Marquand, who's going to talk more in depth about making these kinds of images more accessible to the public.
Thanks, Kelly. Sorry, I have a bit of a frog in my throat, so hopefully that'll go away. Let me just share my screen. All right. So I'm going to talk a little bit about my own sort of journey through this process. And for those of you who don't know me, I've worked for NASA's Chandra X-Ray Observatory for about 25 years. My role is visualization scientist, but I like to think of myself as essentially a data storyteller, someone who gets to tell stories of the universe with data. And the data that we all start out with, it's just a stream of ones and zeros. And so what's on my screen is quite literally that. It's just a huge plot of ones and zeros. This is an actual clip of some of the binary code, the streams of ones and zeros from an image of Cassiopeia A, which is a supernova remnant that we will see in our next screen. So this image of Cassiopeia A, it's a beautiful sort of orangey, almost fiery looking debris field that's left over from the star that exploded long, long ago. And at the center of the image is a very bright, tiny, orangey yellow dot. And this was the first hour of observation from the Chandra X-Ray Observatory that we released to the public back in 1999. And when I first started working on this data, I was super excited. Sorry, I'm still losing my voice. Hold on, let me take a drink. Yeah. Okay, let's see if that's better. When we first started working on this data, it was definitely a learning curve to be able to work with the data to represent it in any sort of visual form. These are X-ray photons. This is really high energy material of our universe. The X-ray universe is quite different from other types of like optical light or infrared light. The X-ray universe is a bit photon starved, they call it. There's not as many X-ray photons or packets of energy out there in the universe as there are, say, optical and infrared. So we really have to make the most of our image work. And after a few years, we've collected more and more data of Cassiopeia A, this beautiful exploded star. And now on my screen is an image with about 1 million seconds worth of data that we've now color coded by chemical emissions. So the iron is purple, the silicon, the sulfur, the argon, the oxygen, those are green, yellow, orange, pink. And then there's this beautiful blue shock around the perimeter of that exploded star. And so as we started developing these techniques, it took me, kind of a few years to, I guess, develop the basic image processing techniques that we had. And I sort of realized along the way that I was only concentrating on visuals. And then in the mid 2000s, a colleague at MIT started working with this three-dimensional data. So it's on my screen now is essentially a three-dimensional model of Cassiopeia A, where we've been able to plot where the light is moving away from us and where the light is moving towards us, broken down into different chemical emissions, different kinds of light, even X-ray light and infrared light, and a little bit of optical light. And once we had this three-dimensional model, it really made me think that we could do a lot more with the data. So we started working with 3D models to create 3D prints. I had some colleagues at the Smithsonian that had 3D scanned and 3D printed President Obama's head. So I'm like, well, if they can do that, then surely we can figure out how to 3D print an exploded star. And so they helped us do that. And we've been on a bit of a journey of 3D printing ever since. We've done some pretty strong user testing of our 3D printing projects. And there are a number of like best practices that we've learned. If anyone is interested in talking more about that, please let me know. We have a paper that I'll drop into the comments that you can take a look at later if you like. But essentially things like size, resolution, quality, the access to the data, the quantity of these models, all of those are really important keys to making sure that people who are blind or low vision really had strong and accessible connection points to these different kinds of data in 3D. And since then, we've been growing a library of these 3D printable objects. But it's really hard. It's really hard to get this three-dimensional data, right? It's really hard to understand the light that's red shifted versus blue shifted and to be able to create these three-dimensional models. We can do additional kinds of 3D printing through like tactile mapping, where it's kind of like just a simple two-dimensional plate that has either the energy or the brightness or whatever that's raised as a bump map. We can do that too, but to get these 3D models, it's a little bit of a work. And so during the pandemic, we switched to using sonification, which is just this translation of information into sound. This is a pretty growing area of research in astronomy, but also other fields as well. There are a number of colleagues that have been doing work in this, from Wanda Diaz and Gary Foran to others. And some of you, I believe, are on this call even as well. And this has been a really fun project for us because it, again, is taking data that, particularly because we're working primarily with X-ray data, is invisible to everybody, right? There's no human that's able to naturally see X-ray light. And so it's all a process of translation. And as Kelly talked about, we can make choices to be able to create an image. We can also make choices to be able to create a 3D model, or we can make choices to create a sonification. So I'm going to play one quick example of this sonification that I think helps exemplify why this project is so endearing to me, at least, and to a number of others. The image that I have up on my screen, it's called the Chandra Deep Field South, and the image is scientifically pretty important. It was the deepest X-ray image that we've ever been able to capture. Chandra looked at this patch of the sky for over 44 days, and there's a lot of real sciencey goodness in here, but the image itself is a bit boring, to say the least. It is a black rectangle with a bunch of like multicolored confetti sort of strewn across it. And the image does not really get across the point that this is pretty scientifically interesting. What this image is essentially a representation of thousands of black holes in our universe and galaxies with very incredible, powerful, supermassive black holes at their core. But when we take that information and translate it into sound, we're mapping each of those points of light, each of those black holes, according to their energy level, where the lowest energy X-rays are the sort of low sounds and the highest energy X-rays are the high sounds, as it scans the image from the bottom to the top. So I'll play a quick piece of this, and you can hear this beautiful field of thousands of black holes. Now you can't hear it through Zoom, but the sound is actually in stereo. So if you're listening to it directly with your headphones, you can actually sort of feel yourself immersed in this field of black holes. Another quick example that I'll play is an image of the galactic center. This is kind of like the downtown of our Milky Way. This is an area around Sagittarius A star, the very supermassive black hole at the center of the Milky Way galaxy. And that is the bright white area on the lower right side of the image. But this image combines 3 different kinds of light. It combines the X-ray light from Chandra, it combines infrared light from the Spitzer Space Telescope, and it combines optical near-infrared light from the Hubble Space Telescope as well. And it's a beautiful image. It's got these great visuals. It's blue for X-ray, it's red for infrared, it's yellow for the optical, and there are all of these sort of bits and pockets of hot gas and this beautiful arching material in the optical light. But it's very, very busy. And so when we listen to it, when we take that information, we translate into sound, we get a different sort of sense of this area around our supermassive black hole. And so in this sonification, we've attached the lowest energy material from the Spitzer Space Telescope to a soft piano. The sort of mid-range material from Hubble is a violin, very plucky. And the highest energy material is like a xylophone glockenspiel from Chandra. And so as we sweep across the image from left to right, you can sort of get a sense of those pockets of information where the violin sort of has its own solo moment, and where the sort of soft piano kind of carries you through all of that cooler gas and dust. And then over on the right, we have this crescendo where there's just a real tremendous amount of high energy material that's being detected by Chandra as well. So you'll hear some of these little diva moments as solos as we scan across, and then you'll also hear where the ensemble sort of works together in a little bit of beautiful harmony. So here we go. feel like it's a nice little zen bit of sound for, well, for me, for the morning, for you, wherever time zone you're in. But really, this image is very, very dense, very busy, and it's a data set that I've been very familiar with since we first made it back in 2008. And the first time, like, I heard all of those sounds right after that sonification had been created, I thought of the data quite differently. Those bits of harmony just made me go back and look at, oh, right, what is that, right? Those little plucky violin moments stood out in new ways, and the interesting crescendo of the X-ray data was really interesting. It was just something that, again, I know this data really well, so to hear it for the first time, it was just a lovely different kind of expression of the data that I don't think I was quite expecting or prepared for. So the sonification project has been pretty popular. We've had like billions of listens around the world. We've had just incredible response overall, but still it felt like something was missing. And that brought us to Christine and JJ's work. And Christine and JJ will be talking in just a couple minutes. But I came across their podcast talk description to me and listened to them describe a SpaceX launch, and was completely enthralled by how they approached that excitement, that energy, that scientific importance of that launch with a real sort of almost poetic response. And as someone who is a bit of a sucker for poetry and also loves science, I really appreciated that sort of intermingling of the ability to describe things in a scientifically accurate way, but also a very compelling way. And we've been working together ever since. We launched a project for Chandra back in January of 2021, because I really wanted to have each new image that was released from Chandra be accessible in a way that was just very compelling, very richly described, no matter what it was we were releasing. If it was an image like we've been discussing earlier, if it was a time-lapse movie, if it was a sonification, for example, if it was an illustration of something we can't see with Chandra at all, we really wanted to have this rich discussion be released in real time. So there was no delay, right? The sonifications take time to be able to release. 3D modeling and 3D printing can take time, but we wanted something truly real time that could go with the images everywhere they propagated out into the great interwebs, as they say. So we've been doing that. We provide this information in a basic text format. We also provide recorded audio formats. We have those populated out as an XML feed, so you can listen to them sort of one after the other. We shorten these rich visual texts into alt text, so the shorter alt text for web and social media. We use them as keywords in our metadata on our image files in themselves. We use them in PowerPoint files, etc. There's like no end of being able to reuse these materials. And I'm going to let JJ and Christine talk about the detail of the technique that we're using, but essentially there's two key things. One is that it's important to describe the image as it appears, yes, but without scientific meaning. It was really an unsatisfying exploration for people who are blind or low vision. And so what we've done is take an integrated approach where we're combining the explanation of the science with a description of what the visual viewer would be seeing. And then we're really testing that very well, and we're trying to make it something that's like an integrated package. The second part of this technique is that style of the text is pretty critical. And it's something that sort of made us reflect on all of our texts in general. So for someone who's a 9 scientist, some of our descriptions, they can be pretty dense, complicated things, right? Chandra science can be a bit more abstract. We're talking black holes, exploding stars, magnetars, X-ray binaries, like all of these concepts that are pretty intense, right? Not just in their energy level. And so being able to describe that information in a way that made sense, well, we had to couple it with making sure that we had shorter sentences, lots of commas, making sure we're using proper nouns, so that instead of hearing it sprinkled throughout a description, you replace it with the proper noun of the object. That lets the person's brain kind of capture that information and focus on the meaning of the sentence versus just trying to remember what does that it refer to. And the shorter sentences with the commas really helped with the pausing and the cadence to let folks kind of absorb it. And I'm just going to give you an example of the cat's eye video visual description. I won't play the sonification, but just to give you a little tiny taste of what these visual descriptions are taking shape as. It reads, the shape is the Cat's Eye Nebula, a huge cloud of gas and dust blown off of a dying star. The concentric circles are bubbles expelled by the star over time. The dust cloud resembles a translucent pastry pulled to a golden yellow points near our upper right and lower left, with a blob of bright purple jelly inside the bulbous pale blue core. The jelly-like center represents X-ray data from Chandra. The outer cloud and translucent circles represent visible light data from the Hubble Space Telescope. This is, as Christine and JJ know, probably one of my favorite visual descriptions ever. I don't even eat much jelly, but I just really enjoyed this analogy to food and just how colorful that imagery can truly be. So this material that we've been working on, these visual descriptions, they've really helped us inform like not only how we write other captions or press releases or descriptions overall, they've also kind of helped improve our search engine optimization by using more proper nouns, for example, by really paying attention to the wording. It's really helped improve what we do on Chandra kind of anywhere in our digital sphere. And there are new IPTC accessibility tags, by the way, if you use products like Photoshop or other imaging software. IPTC is the international standard for metadata tagging, and they now have that metadata tagging with the rich visual description tag built right in. So if you're using like Adobe Bridge, for example, you can actually incorporate your visual description tag right into the metadata of the image itself, so that no matter where it goes, it will carry that description with it. So I will just give a little bit of feedback before tossing it over to JJ and Christine. We've had some user groups test this material, and the visual descriptions have been responded that they're better than sonifications, that they really help compress this complex data. They help remove noise, relating it to something helps reduce the mental load. One person said it brings the aesthetics back to description, like the pre-TV radio announcement days. There was more feedback that, they hope others can implement this technique. They wanted James Webb to have this from day one, and they did, that this really helps fuel the imagination. So all of that I've talked about this morning or this afternoon or this evening, wherever you are, is to say that like when we're all designing the universe, that availability of data, it really doesn't equal that accessibility and that equity of data. It took me quite a few years to kind of get my act together to kind of realize that this data does not have to just be visual, that it can be expressed in multiple ways. And I think it's really exciting not only to understand how important that is for communications purposes, but also for bringing in the next generation of scientists, right? This is like an important tool that I think could be leveraged for even research itself. These ideas of making science accessible is really important, I think, not only just for the outputs, but also for the inputs. So a quick shout out to all the folks that have been involved in these projects. This is not a me thing. This is definitely a we thing. JJ and Christine are here from our visual description team, but there are other folks involved too, of course, Peter Edmonds and Megan Watsky, Kelly Williamson, April Jubet, and then a long list of credits for the sonification team and for the 3D teams as well. So many, many thanks to those. And I'll just end with a quick reminder of the agenda. I think we're on time okay-ish. We're going to toss it over now to JJ and Christine to give you a deeper dive into how to write the visual descriptions. Then we're going to take a break. Then we're going to go into a discussion with some representatives from the blind and low vision community as well. Nick, Cheryl, and Christine, I think, are all here today to be able to do that. We'll go into another break, and then we'll go into a little bit of a deeper dive of an anatomy of a visual description, if you will, and talks about language translations before we kind of go into the housekeeping and the share outs. So with that, let me just stop sharing for a second and relaunch these slides for JJ and Christine.
Hello, everybody. My name is Christine Malik. Thank you, Kim, for setting the bar for non-scientists. That describes me. I'm a member of the blind community and a lifelong enthusiast for astronomy. And so I came to this work as a consultant working with JJ, who's a professional audio describer. And so I'd like to start by just giving some basics on what description is in a kind of historical sense for anyone for whom description is new. Now, everyone has done description. If you've ever described something that happened to a friend, oh, we were at the bar and this thing happened, or described an outfit that you once wore or a beautiful place that you stayed. Everyone has described things to other people before. So it's a translation into words of something that is visual. So historically in culture, it has been done in things like television and movies. There might be a secondary audio track. In museums, there might be a written description of an image. So the art and techniques of audio description are, pretty well established. So when we started bringing these techniques to describing astronomical images, some of the techniques were in place and others we had to sort of experiment with. And so uh, why is this great? I can say personally it's great because it gives me as a blind person primary access to the images, to what they look like, to what they mean, to what they represent. They make blind and low vision people part of the public conversation. Um, I'm particularly interested in what they have to offer for blind kids today. Um, when I was growing up, there was nothing like this. And I sometimes wonder if I had had, kids growing up today with this kind of access are much more likely to end up in STEM fields than I was. Also, neurodiverse people really appreciate another way to experience data and images. And as Kim mentioned, with the sonifications being so popular, it's just good public education outreach to have different ways to reach people when you're presenting content, and especially when it's challenging content, such as the hard science that we're talking about. And I mentioned that museum images, for example, or art pieces are often described. And I'm going to make a bit of a comparison here that's going to be helpful in discussing why we choose some of the techniques that we do. So imagine you're at a museum and you read a description that says, this oil painting on canvas depicts 5 dogs sitting around a table playing cards. Lots of information conveyed in that sentence. It's a very well written sentence in description terms. You know the medium, you know what it's on, you know what it's representing, and you know what the action is in the image. Thing is about that image, everyone knows what a dog is and what a table is, and playing cards. Those are all very well understood cultural meanings, and so that's a simple sentence to use. For this work, you're dealing with stuff that, as a non-scientist, I can attest it can be very challenging. And so, uh, some of the techniques that we have found, that Kim referred to, is integrating the science with the description. So when JJ and I first started with this work, JJ took his classic approach, which is describe what you see. And so I would read that and I'd feel a little flat, and then I would try and read the scientific description and then work really hard with my tiny non-scientist brain to integrate all of that into something that made sense. And as JJ and I worked together on how to do this better, what we decided is that the standard objective approach to describing wasn't going to work so well in this context. And what was going to work much better is taking the science and integrating it into the description, so that in the examples that you've heard so far of written descriptions, you're getting not just what it looks like, not just what you're seeing in terms of what it looks like, but what the things actually are. And so it's a version of description that's different from what you typically get, say, in a museum or in a TV show or in a movie. And that's one of the things that we figured out, was that you need to be integrating. And so my role in the description process is as a consultant. And so JJ will work with the image, write a description, and then I'm reading it for a lot of different things, but basically to assess whether it makes sense to someone who's not looking at the image, and particularly to someone who's blind, because it brings up a lot of considerations about your word choice, how you write, how you choose to describe. And so there's some techniques that we've developed overall. And JJ, I'm going to ask you to sort of run us through some of the more specific things that we've figured out.
Thank you very much, Chris. Hello, everyone. My name is JJ Hunt. I am a describer. I've been describing for 20 plus years. Just a short self-description. I'm a middle-aged white guy with silver hair, a bushy silver beard, and I'm wearing black framed glasses. What's on screen right now is an image that that we have described, and this was one of the first images that we came across. That as Chris referenced, we started out with an image description that was pretty straightforward, which was, here we have an image of a quasar with an X-ray jet. The thing is, most people outside of this room, blind or sighted, don't have a solid understanding of what a quasar is, let alone what it might look like. And, aren't jets airplanes? And how did those astronauts take a picture of this anyway, right? So what we found to be far more effective, as Chris said, is integrating the scientific explanation with the description, what the subject is and why it matters while we're describing what it looks like. So before we fully break down the technique, I'm going to read you another example of a science integrated description that we wrote. Here is the description we wrote for V404 Cygni. And what we wrote is, this composite image features a series of incomplete concentric rings in a black field dotted with gleaming white, yellow, and golden stars. The giant rings are light echoes, a phenomenon similar to echoes from sound waves bouncing off of hard surfaces. These light echoes were produced when X-rays burst from gas near a black hole at the center of the image and bounced off of cosmic dust clouds. Black holes themselves, like this one in V404 Cygni's binary system, are invisible. Here, the X-rays are rendered as hazy blue neon rings. The smallest, near the center, is the brightest and the most substantial. The remaining concentric rings are somewhat wispier, but are much larger and extend beyond the edges of the image. These rings are not clearly defined like the clean ridges on a record album. Instead, they appear vague and blurred, resembling curved tire marks left in wet snow. The rings are incomplete, with gaps at our upper right and upper left. A string of gaps appear in a horizontal line across the middle of the image, as if portions of the neon blue X-ray rings were removed with a straight swipe of an eraser. These gaps show the edges of Chandra's field of view during the observations, or the sections of the field Chandra did not observe. Okay, so let's look at the architecture of this description, just to break it down. With visual description, we often use a very helpful system to structure our writing. We talk about overview, we then organize and elaborate, and then we add our details. So we can break that down task by task, starting with the overview. So it's important to remember that a description user is likely approaching the image with little or no prior information. A sighted user will already be looking at the image, but a blind visitor to your website will not. So right off the top, you need to give a broad overview. This is an overview of the phenomenon being depicted. It's an overview of what the image looks like. And you also need to include the type of image that it is, right? Because this might be a photograph, it might be a composite image, it might be a digital rendering. For V404, we wrote, this composite image features a series of incomplete concentric rings in a black field dotted with gleaming white, yellow, and golden stars. The giant rings are light echoes, a phenomenon similar to echoes from sound waves bouncing off of hard surfaces. So we start with the type of image, right? It's a composite image. Then we provide an overview of the visuals, right? Incomplete concentric rings, black field dotted with stars. And then we give an overview of the phenomenon. The giant rings are light echoes. And the order in which you do this, it really depends on the piece and the needs of the piece. Sometimes no description of the visuals is going to make any sense until a listener has a basic understanding of the science, but it might be the other way around, right? It's all about trial and error. It's just about practice. Going back to the idea of the quasar and the jet, we opened with this artist's illustration features a close-up view of a quasar and its jet, which resembles a beam of multicolored light shooting from a spiraling red ring. So in that case, we were able to fold all of the elements, the phenomenon, the visual, and the type of image into a single sentence. Sometimes you have the opportunity to do that. Sometimes for simplicity, it's easier to break it up into several sentences for your overview. So that's your overview. Once you've done that, the end user comes into this description with a basic idea. They've begun to paint their mental picture. And now what you need to do is organize your thoughts. Organizing your thoughts is extremely important when you're writing complex text because there's so much information going on. And if you're only taking this information in an audio, if you're not taking it in visually, you're just hearing this information, having it well organized is essential. And as you're organizing, you're elaborating on the elements that you've already outlined in your overview. So there are lots of different ways to organize. You can organize by visual element. You can describe each visual element and then pair that explanation with an explanation of the science, or you can go the other way around. Start by organizing by different elements of the science and pair that with descriptions of the visuals. You can do an extensive description of the phenomenon followed by a description of the visuals, and you link those two paragraphs basically using consistent language, or you can go the other way around, do an extensive description of the visuals and then go to the phenomenon. Every description is different, and you just need to be organizing according to the specifics of the image and the complexity of the phenomenon. So while you're organizing, like I said, you're also elaborating. For V404, we felt that elaborating on the phenomenon would help users understand and contextualize the visuals. So we wrote, these light echoes were produced when X-rays burst from gas near a black hole at the center of the image and bounced off of cosmic dust clouds. Black holes themselves, like this one in the V404 Cygni binary system, are invisible. So we further explain the phenomenon and make sure that the user understands that they're not missing anything with regards to the black hole. It is invisible. So in this case, we're not only describing what is there, but what isn't. You don't want to leave an end user hanging and thinking that they've missed something, they haven't understood something. In this case, it was important for us to say, no, it is invisible. So then we elaborate on the visuals organized by concentric rings. So for Chandra releases, we have organized based on visual elements, right? First, the spiraling red quasar, then the beam-like jet. We have organized based on light spectrum layer. We've organized based on primary image and then the inset close-up. Lots of different ways to organize. And then you're going to add your details. And you're doing a few things when you're adding your details. First of all, you're ensuring that the visual details you've already included create a complete picture, but you're also making the description rich and evocative. When you're first starting to do this kind of work, it can be really helpful to read your descriptions to a colleague that's just outside of your field, and then show them the image and see if what you described matches the mental picture that they've started to create. And if it doesn't match, one of the things you can do is flesh out your details. Similes and analogies can be very helpful when describing uncommon visuals. And a lot of the visuals you'll be describing will likely be of the uncommon variety, right? Be aware that not all analogies will be understood and appreciated by every description user. You need to try and find common reference points and elaborate if necessary. And we're going to talk more about this later. We have an international crowd here today. A simile or analogy that might work for us in North America might not work if your context is completely different, right? right? In V404, we used several, analogies. And for example, similar to echoes from sound waves bouncing off of hard surfaces. We talked about the rings resembling curving tire marks left in wet snow. We wrote as if portions of the neon blue X-ray rings were removed with a straight swipe of an eraser. So when you're adding your details, you can add new sentences if you'd like, complete new thoughts, and then you can describe the important details that illuminate a specific element of the phenomenon at hand, like the mention of the missing parts of the ring. But you can also go back to earlier sentences that you've already written, and just add descriptive words that help bring your description to life. Hazy, wispy, gleaming, these are all words that we added into our when we were working on V404. So one of the reasons we use visualizations, as Kelly very wisely said, is to help people both understand and appreciate, right? We want to inspire awe. And to do that, we use color, composition, texture to create these rich and engaging images. And one purpose of a visual description is to help users who are blind or have low vision not only understand, but to appreciate the visualization and the phenomenon. We want to be inspiring awe in users who aren't taking in these images visually. And to do that, you need to use lush and evocative language, and you need to draft an engaging, description-rich story of the image you're presenting. So let's look at how all of this technique, this architecture that we've just described, let's look at how all of this breaks down and plays out in an example from the James Webb team. So we didn't write this description. This was written by the James Webb team, but as you'll hear in this example, the Webb team is using a very similar approach in their description writing. So this is their description of Carina NGC 3324. They wrote, the image is divided horizontally by an undulating line between a cloudscape forming a nebula along the bottom portion and a comparatively clear upper portion. Speckled across both portions is a star field, showing innumerable stars of many sizes. The smallest of these are small, distant, and faint points of light. The largest of these appear larger, closer, brighter, and more fully resolved with 8-point diffraction spikes. The upper portion of the image is bluish and has a wispy, translucent, cloud-like streaks rising from the nebula below. The orangish cloudy formation in the bottom half varies in density and ranges from translucent to opaque. The stars vary in color, the majority of which have a blue or orange hue. The cloud-like structure of the nebula contains ridges, peaks, and valleys, an appearance very similar to a mountain range. 3 long diffraction spikes from the top right edge of the image suggest the presence of a large star just out of view. So again, they begin with an overview of the visuals. The image is divided horizontally by an undulating line, right? Then they organize. First, they describe the star field. Then they describe the upper portion. And then they describe the orange cloud nebula, and they elaborate on each element as the description goes on. And then they've added some nice little details, right? The cloud-like structure of the nebula contains ridges, peaks, and valleys, an appearance very similar to a mountain range. They talk about the wispy streaks. They mention diffraction spikes, right? So the same highly effective approach, but written by a completely different team. So their choices are going to be a little bit different. And that's a good thing, right? While the content that we are all describing is based on data, we shouldn't forget that every writer is approaching their work with their own worldview. So having a diversity of perspectives represented in these early days of scientific description writing is really something we should be striving for. Chris, did you have any thoughts on this James Webb example that you wanted to share?
Yeah, it makes me think a lot about the use of analogies and similes and comparisons in description writing. And I'm not in any way saying there's a right or wrong here, because there isn't. But I'm going to point out a couple of examples where it can be problematic. So for me, as a totally blind person who grew up totally blind, things like clouds and mountain ranges are abstractions already. So for them to be used in a visual description is it's kind of stretching my comfort zone around what I understand. Now, keeping in mind that the description consumer may be someone who had sight at one point or someone who has partial vision, so clouds and mountain ranges make sense for them. I only raised the point to say that the closer you can get to comparisons that are going to make sense to everyone, the better. So I had a great example recently. I was in a workshop about the solar system being taught to blind adults. And what the presenter did, now this is not description writing, but it's an example of how we can start thinking about this stuff. So she said, put your left hand out, palm up in front of you, fingers pointing away from you. Take the index finger of your right hand and start to draw a line down the index finger of your left hand, down the finger around the base of the palm, and make a curve. Then go to the top of your middle finger. Draw a line, trace a line down inside the other curve. Start at your ring finger, down the finger. And so what she's doing is, and she said, when you're done, that's a spiral galaxy. And so you can't necessarily use that in an image description, but the reason that stuck in my mind was it's so embodied that everyone is going to get it. Everyone's going to understand it. So my point is that it's a beautiful piece of writing, and I was so glad that that alt text came out when the first James Webb images did. So that's really the big point I want to make, is that I was so happy that that was included, and it received a startling amount of great press, which I'm very happy about. But in that particular one, it did make me think about the use of analogy and how we should be careful with that. And so, for example, another example is JJ sometimes uses food, as we saw in the pastry example, which Kim always enjoys the food analogies. And so, depending on where you are, maybe you want to say it looks like a dumpling, or it looks like a burrito, or wherever, whatever cultural references make sense. But just to say that analogy, comparisons, and similes are incredibly valuable, and they bear some close consideration. So try not to use something like it resembles a bird in flight, because that's an example that a blind person is probably not going to be able to relate to.
Mm-hmm. Yeah, I'll just follow up on that, Chris. If you are going to use something like it resembles a bird in flight, why does it resemble a bird in flight? Can you break down what it looks like? A bird in flight with wings flapping, with one wing higher, one wing lower. If you can take that example and get down to the specifics, because as Chris said, you are speaking to folks who have no relationship with sight. They've been blind since birth, but you're speaking to others who have had different relationships with sight. And this brings me to a couple of questions that have come up in the chat about color. Should we be describing color? How does color make sense to folks who are blind, low vision? From my point of view as a description writer, as we say, we're writing for a variety of different people. And lots of folks who are blind still have some relationship with color, either because they can see a little bit of color. They can have, perhaps some people have a bit of color at the periphery. Some people only see in vague color shapes, but others will have had a relationship with color from before they lost sight. And even if they haven't had that relationship with color, some people have a contextual understanding of color, a societal understanding of color. So they might understand that blue represents cool, red represents hot. Again, this changes culturally, right? Some people might think that black represents a death and the funeral, whereas other people might say, no, that's white that represents death. But using description, integrating that description or the color into your description is totally valid. It's totally appropriate. You just have to know that not everything is going to be speaking to every end user. And just being aware of time, I thought I'd quickly go ahead and kind of wrap this idea up by giving you some tips when you are writing your own description. We're going to be kind of composing a description together later on in the workshop, but also, as you move forward and hopefully start integrating this into your own practice. So when you're writing descriptions, you want to be concise, right? As Kim mentioned earlier on, you want to use short sentences. Here, the X-rays are rendered as hazy blue neon rings, period. The smallest near the center is the brightest and the most substantial, period. This helps with comprehension, and it works really well with screen readers. More on screen readers in just a second. Also, as Kim mentioned, using proper nouns consistently and regularly. The giant rings are light echoes, a phenomenon similar to echoes from sound waves bouncing off of hard surfaces. These light echoes were produced, right? When you use the same name over and over again, it reinforces, it helps avoid confusion. Clearly connect the visuals and the elements of the phenomenon, right? So we write, the giant rings are light echoes. Or if you want to reverse that sentence, these light echoes, which resemble giant rings, you want to make sure that you are very clearly linking the elements of the phenomenon and the visuals. You don't want to be vague about that. You want to be very, very clear. And like we just said, don't be afraid to describe color. Use punctuation wisely and liberally. Lots of commas, Oxford commas, semicolons. And try not to use dashes, though. Many users will be accessing this content using screen readers or text-to-speech technology, and often at very high speeds. And that tech is pretty well programmed to read punctuation with proper inflection. So commas and the like are going to slow down your description. They're going to present your descriptions more clearly, which really helps with comprehension. But dashes, for some reason that I don't understand, are not read by all screen readers, which is kind of odd. And speaking of screen readers, test with one. Before you're done your writing, you can use your computer's built-in screen reader to hear your description. And you'll learn a lot about how your writing is being consumed, what's working, what's not, and where the gaps are when you hear your description. Chris, any final thoughts before we pass it over?
I just want to really reinforce the punctuation, the excessive use of punctuation, because this material is so dense that I often slow down my screen reader when I read this stuff, and having the natural inbuilt pauses that commas and periods create in the screen reader is extremely helpful. So I'm a big fan of the Oxford comma. I probably overuse punctuation in my writing, but don't be afraid of the comma and the period. They're very helpful.
Wonderful. Thank you so much. Okay, I believe we are going to, hold on, let me just get back to my window. Okay. I think we're going, are we doing the break now, Kelly, or is it after the discussion?
I think what we had in the agenda was to break before the discussion, but there are some questions in the chat that I wonder if we want to talk about now or if we want to wait till later.
I would love to do them now if you think we have time.
Yeah, sure. Absolutely.
Right. Do you want to read a couple? Which ones you want to do?
Yeah, JJ talked about a few of them, namely the stuff relating to how people with blind vision, low vision or blindness, complete blindness, interpret color. But one of them was about a challenge with social media. So the alt text for social media is often constrained by character limits. And what should be prioritized? Should we focus on visual descriptions, or should we focus on the science, or maybe just try to shorten everything down? Or maybe it was suggested to just move it completely from alt text into the main image caption.
So I can tell you what we do at Chandra. So at Chandra, we pretty much tend to just try to shorten everything down. If we're using a short alt text, like the 240 characters for HTML or whatever, we just try to take everything and just kind of down until we've got something that makes sense. However, we do kind of like a multi-step process so that even once you go to the web page, we've got the full text link for the visual description in all of its glory. We provide the narrated version of that right next to the image as well. And then we also embed both the short alt text version and the longer visual description version into the metadata of the image itself. So if that image goes to the Worldwide Telescope, if that goes to some sort of planetarium software, if that goes into Google Images, that alt text and the rich visual description text, which are both the IPTC friendly tags now, travel with that image in perpetuity. So we try to do a combination of providing the full versions as many places as we can, and then using a version of the alt text that's just a condensed version. I've had a really hard time like picking out the best parts to include in alt text because the characters are so short, but I try to get a little bit of both. I try to get a little bit of the visual description and a little bit of the science tucked into that micro version of the full rich visual description. So I hope that helps.
JJ speaking, if I can just chime in real quick, the overview, if you've written a pretty solid overview, a lot of what can go into an alt will probably hopefully be in that overview statement. So you will still, as Kim said, have to kind of Frankenstein it a little bit and pull in other parts, but hopefully a fair bit of the information is already nicely packed into that overview statement that you've written because you're so highly organized.
I'll just add too that if you're, say, appending the alt text to a tweet or something, or some kind of social media post, that post may already contain a lot of the science, and so you can tailor your alt text to just make sure you're using the alt text as efficiently as possible and not repeating what's in the post itself already.
Any other burning questions from the chat, Kelly?
Let's see. Well, that was great. Thank you so much for that. Another question, I think maybe the last one before we'll break is there a preference for, or maybe like a best practice for where on a web page information lies that would be best maybe for screen readers or for navigation purposes?
Well, I can tell you for the Chandra website, we're actually in the midst of a huge web upgrade, and in the new version of the site, we're actually building it right at the image itself so that you'll be able to like clearly access it and also get it onto the image essentially like front and center, as well as having additional text links to it. We tend to keep it in just plain text format instead of doing a PDF because our user feedback has been that text is better than PDF, and a doc is fine as well, but at least text is very sort of server generic, if you will, or app generic. So that's kind of how we're approaching it, though other people have put it in different locations as well. Christine, I don't know if you want to weigh into easy access point for you.
It's always easier if you don't have to open a PDF or a doc file. So unless it's, really big, it's nice to have it integrated somehow in right onto the web page itself.
Okay, great. So why don't we take a break for 5 minutes? So come back. Unless Matthew, do you want to add something? I think you're muted, or we're not hearing you. I don't hear you.
Hear me now?
Yes.
Right, sorry. Hi, this is Matthew Isidro. I'm comms manager for the Square Kilometer Array Observatory. This is just a follow-up question on the caption and alt text question. I was just wondering, and Amelia actually touched on this in the chat, exactly this point, whether we should differentiate between what we write in an image caption and what we write in an alt text. So, for example, on a web page where we publish our press release, we'll have a caption under the image, and that caption is typically very different to what we write in the alt text. I guess the question is coming from the point of view that the alt text, which is much more descriptive, is totally invisible to people who are reading, you know, are cited, are reading the press release. And so I'm just wondering whether it would be good practice to actually use the alt text as the main caption for everyone to see. That's,
So
I guess, a question to the room.
I can give you our perspective that we are starting to do that ourselves in small amounts. Like we're trying to build some of that image description into the caption, because we provide a press release format for Chandra releases, and then we provide an image caption that's like a slightly boiled down version. And the image description, we're starting to try and incorporate parts of it to there. I can definitely see a future where we actually just have the text just straight out embedded into it as like a further part of the image caption itself. I think that would be really useful. We've got interesting research from projects that we've done over the years that show that folks really like having a guide to these images. So if you're sighted or if you're blind or low vision, pretty much everybody can benefit from having the way it was likened was like essentially having an astronomer next to you pointing out the things of interest, right? And that's sort of what these image descriptions are doing. They're sort of like having someone next to you that are pointing out like, these are the interesting things to see. This is where the science is. This is kind of what we're dealing with. And I think one of the additional benefits of these image descriptions is they really do sort of fulfill that role as well. So yeah, long answer, shortened down. I think that we really should be doing that, and we are trying to move in that direction as we go.
Great, thanks very much.
Okay, there is a lot of activity going on in the chat, but I think maybe we should break now and come back in 5 minutes. We'll get to the rest of these questions, I promise, at the end. We have a little bit of time set aside for some question and answer. So keep them coming, but keep them in mind too that we might not get to it for a little bit. But yeah, so come back in 5 minutes, 18 past wherever you are, or if you're in a half time zone, I'm not going to try to do that math. So take a break, grab some water, come on back, and we will continue with the discussion with Nick, Cheryl, and Christine. All right, everyone, if we could start making our way back. So Kim, I don't know if you wanted to introduce the people that will be joining this conversation.
Sure. So hi, everyone. Welcome back. Believe we have Nicholas Bond with us today. He's an astronomer from the UK. We also have Christine, who we've been talking with already. And we have Cheryl Vogel-Hatch as well, who I believe is on, though I'm not 100% sure. I've seen everybody's names go by. That's who I believe we'll be talking to. So yeah, we'd love to just hear from everybody, perspectives, interests, and all of that. And Kelly, I don't know if you had any leading questions you wanted to start out with.
Yes, I did. Sorry. Let's do you want to stop sharing your screen and I'll start sharing mine? Okay, so I think, there's a lot of discussion going on in the chat. So I think that maybe this is not super necessary, but just to get us started to think about these issues and these things that Chris and JJ and Kim have been talking about, bringing that into our own practice. I'm sure lots of you actually have experience with tactile images or sonifications or image descriptions or some other way of making images accessible to a broader audience. For the next maybe few minutes, do you maybe want to share about what those experiences are? And you can either put yourself in the chat. I know, actually, Ria, you've been talking a little bit about you were a teacher working at a blind school or a school for the blind. Ria says in the chat, the understanding of verbalized images has a lot to do with differences in the acquisition of basic concept formation, although differences in vision are also relevant. So that's something that they noticed. Does anybody else want to talk about maybe some of their experiences working with this community in particular? Or should we just jump straight into discussion? All right, maybe we'll just move straight into discussion then. There are a lot of questions that have come up in the chat that I think are really important. So I will stop sharing my screen and maybe we can just be together in this Zoom room. So in the chat, folks have talked about, so I don't know in what way you wanted to structure this, Kim, or Nick, Chris, and Cheryl. But there are some questions in the chat that we could go through, or you could just start discussing based on the experiences that you've had working with these kinds of materials.
Yeah, I'd love to hear from Nick and Cheryl and Christine, sort of just maybe perhaps a quick introduction to how they're, what their responses are to this, how they're sort of processing all of this, and then also what they would recommend, if anything. But yeah, I'd love to hear from them first to kind of get us started.
This is Christine. I'd actually love to hear from Nick and Cheryl about, as I said before, I'm a non-scientist and I grew up with such an interest in astronomy, but I could read about it and watch science documentaries and read science fiction, but I wonder, um, uh, I'm Cheryl, I'm sorry, I don't know your background, but Nick, you're an astronomer and visually impaired. So I wonder about how you feel about the shift towards access and having written description and sonification, and what your experience was as a kid, uh, gearing towards a career in STEM, and did that come naturally, or was it something you had to work really hard at? And I just wonder about your perceptions, both of you, on the shift toward access through sonifications and descriptions.
I can start off if you'd like.
Please, yeah.
Yeah, so I mean, for me, so my interest in astronomy was something I developed at a really, really young age. So I'm blind from birth, but I have a tiny bit of usable vision. But I grew up in a very, very dark part of Australia. So I spent a lot of time outside at nighttime with my family, all of us looking up at the night sky, and me trying to see stuff and them describing a lot of what they could see to me. And I guess me sort of building my passion for astronomy that way. It's definitely something that I had to work really, really hard at. So I decided again quite young that I wanted to be an astronomer when I grew up. But this was back in the 80s, back in the 90s. We didn't have access to anything near what we do today in terms of assistive technology, it's sort of accessible, like image descriptions, tactile models, anything like that. So I kind of had to make things up as I went along a lot of the time. It involved finding people who were willing to spend the time with me to help describe things to me so that I could understand them. Finding the right teachers who would sort of help me work out ways of understanding the things that I wanted to understand or that I needed to understand. And for me, that sort of carried through even to my university education and eventually sort of to my PhD work as well. It was always a bit of a collaborative process. If something wasn't quite working for me, if I wasn't able to access a particular bit of information or understand something, I would often have to try and find somebody who was willing to work with me to problem solve, to sort of come up with a way of doing things. And for me, at least, that sort of led into the work that I do today. So I run a project in the UK called the Tactile Universe. We make these tactile image plates that we 3D print. They basically trace the brightness of light in an image, and the idea is you can use your fingertips to feel those. But we also pair those images with a lot of image description as well to make sure that what people are feeling makes sense, that we're conveying the right science. A lot of the stuff that we've talked about already in this meeting to do with analogies, use of color, what kinds of things we can relate things to make sure that a broad audience is going to understand what we're talking about really resonates with me as well. The one extra thing that we've had to do, because we pair our descriptions of images with tactile models, we often actually have to order the way we describe things with how we expect our audience is going to, I guess, interact with our models as well. So if we want them to discover a particular feature first, if that's going to be beneficial for that person, then building up an overall picture of what's going on in the tactile image. If we then want them to focus in on more specific details and specific parts of the image, we need to sort of incorporate that into the way we describe our images, either verbally or in a written way as well. And that's probably enough for me, from me for the moment.
Thank you so much, Nick. It's really great to hear about your experiences. Cheryl, I know you were having a little bit of trouble unmuting, but I think we fixed that. Do you want to add your voice here?
Can you hear me? I'm not sure if you can hear me.
Yes, we can.
Yes.
Okay.
Yeah.
Good. Okay. Yeah, so my background is actually in archaeology. So I come to Access for Science through archaeology and also Access to History. I work as a museum consultant now. I have broad interest in tactile models and sonification and image description and all the good things. I find that image descriptions are wonderful things, but there's something to be said for exploring an image independently through sonification or tactile models. So the answer is both and, for tools, not either or. So I'm really glad that these are coming up as both and in these discussions. Let's see, and to answer some of the questions about visual, metaphors, images, etc. It really does depend on what a person. I was totally blind from birth, but I was fortunate as I was growing up to have parents and teachers who were very good at describing to me. I remember kind of early days of clouds are like cotton balls, and the cool to warm concepts for color. I tell people that I have, I think of visual concepts as a language. So if you equate to a language, I would say I have a limited proficiency in visual concepts. I can get by. I can get reds and blues and greens. But about a week ago, I was talking with a friend and discovered that blueberries are actually purple. So yeah, there are things that I miss, but it's a work in progress. And the more people who are trying to make information accessible, the more we're going to get more of these visual concepts out in the world, and non-visual concepts, and having multi-modes of accessing information, the better it's going to be for people, my generation, next generation, and going forward.
This is Christine speaking. I don't know why this didn't strike me more in the past, but just this morning I was listening to, I think it was when Kim was describing something and talking about images and how beautiful they are. And of course, I always have it in my mind that any astronomical image, well, most astronomical images are representations. And so any image description or a sonification is just a different form of representing the data. But I really got sort of thinking about the concept of beautiful, and that when a data set is converted into an image, I'm pretty sure it's done with an aesthetic sense, with a sense of making it look beautiful, pleasing to the eye. And I don't know where description should land on this point, because description is normally thought of as something that should be objective. We should not editorialize when something is being described. You just state what you see. But in public outreach for this kind of science, I'm just thinking about this now. I've never really thought about it, but when a visualization is created, when an image is created, it's done with an eye for beauty, if I may use the metaphor. And so is there a space for that when writing descriptions? And my answer is, I don't know. Because editorializing is something description traditionally avoids. And so I don't know if anyone else has any thoughts about that, but part of the goal is to create, I love how you said this, Kelly, curiosity and awe. I love those ideas. And how can description do that, but still be objective enough to be authentic? End of thought.
Well, no, I definitely like that topic. This is Kim again, because I think it is definitely important. The idea of these images, I think what's always been interesting to me is that a lot of the popular idea is that these images are just snapshots, and they should be completely objective. But these data are being collected by telescopes that are created by humans using software to translate them, that have been written by humans, and then finally being translated in the very end processes by humans. And so I think there is always going to be that human aspect in them. So I can only say that, like, when I'm working on an image, for example, or sonification or whatnot, like, it is a meeting of the two. I would say the science is always driving it. The science is always driving the story, the representation, the extrapolation, the translation, whatever. But I have my own viewpoint, and it's impossible to keep that out, right? Like these data, they do start out as ones and zeros, and that might seem cold and sterile and objective, I suppose, in a way. But again, we wouldn't have those ones and zeros without the humans that built the spacecraft, that wrote the software, that created all the mechanisms for capturing all that information. In each little person that that contributed to that has a part of themselves in it. And I think that's okay. So I think it's just important to make sure that though the science is driving the story, you don't want your own perspective to be overloading that story. That scientific information should always be front and center. I like to think of the sonifications as an example because I think a lot of people hear those sounds and find it, either really awe-inspiring and interesting, but also like confusing. Like the universe doesn't sound like that. No, the universe doesn't sound like that at all to us because we can't hear things really directly in any of that. But it is a mathematical mapping of the information from one form to the other. And the choices of what that mathematical equation, are in the end result are up to us, whether or not we're choosing instruments versus choosing voices versus choosing whatever. For us, we're making the choices that are driven by the science, right? That scientific story that is being told. So yeah, I like to think that visual descriptions are another extension of that because you're still including all that science, but you can add a little bit of that, story and curiosity to it.
Amelia, did you want to add something?
Yeah, Amelia Bayo here. I'm an astronomer at ISO that tries to do tactile material and other kinds of inclusive material in astronomy. And well, first of all, thanks so much for this workshop. I think this is freaking awesome. And yeah, thank you so much. And I think the question or the topic that Christine brought up is it has so many. So I'm going to repeat some of the things that Kim said, but of course much worse articulated. Sorry about that. But I think it has deep implications also on the discussion of communication of science and on science being. Even if we want to say that the description should be science-driven and that maybe is more sterile, it's not so much because we interpret things, right? And I think that's very important in the general communication of science that we convey the idea that this is one possible interpretation, that our knowledge is going to evolve, and that's a good thing. And we have seen it with the pandemic, right? People wanted like clear yes or no answers from science to things, and it's a process, and it's super important that we avoid saying this is the universal truth and how I'm going to describe it is the universal truth that is not going to change, right? And so yeah, sorry, I'm repeating some of the things, but I just wanted to try to bring this point. Thank you.
This is Christine speaking. One thing that's very true about the field of description is that it is evolving, and there's a lot of innovation in what gets described and how it gets described, where description happens. And so I like what Amelia, I like what you said about that there is no cut and dry. And one approach that I've just come up with in my head right now is if your organization is a bit less formal, maybe there's someone who always does the description who has a very particular voice, and is voice, I mean that metaphorically, as in they come from a particular perspective or have a personality. So in the way that I was describing before, where describers are typically taught not to editorialize, that doesn't need to be true, and that description is a field that does change and is still growing. So I think experimentation is completely a good idea. And so there are definitely skills and techniques and important guidelines to follow in writing descriptions, but experimentation and even a sense of playfulness have a place as well. End of thought.
Before I go to Carol, who's raised her hand, Nick or Cheryl, do you want to add anything to this?
So Nick here again. Just one thing that sprung to mind with all of this discussion. So we've obviously talked about whether it's appropriate to use color in our descriptions of images, even if we're working with a totally blind audience, say people who've been blind from birth. I would definitely back up the point that it is absolutely okay, but that it is super important to link that color to whatever bit of physics or science we're trying to communicate, and to really make sure that relationship is sort of in the audience's mind as they're reading that description. The one place, though, where this can backfire is if your audience already has color associations, say they think of particular shades as being warm or cool, but the colors that you've used to describe something in your image are actually the other way around. And what springs to mind here is optical images where if we look at a star, if the light from that star is blue, that's actually a really hot star. Whereas if we're looking at red light from a star, that star will be much colder. And that's the opposite way around from what a lot of people would have in terms of their color association. So that's one thing to bear in mind when we think about all this kind of stuff is, yeah, colors are great, but we do have to be a little bit careful that we're not completely trying to sort of reinvent the way somebody has been thinking about color their entire life.
Yeah, this is Cheryl. I think I remember being on a presentation with Nick last year, and someone was doing blue being hot, and I was blown away. Yeah, and so maybe just assume that the associations run for optical, because that's what people would most likely have had described to them before. I don't know if it's a special case, because I'm not an astronomer, if blue as hot is an extremely common thing. But if you have a book of practices, maybe default should be where you come from optical images.
I think that's a really great point for everybody. I remember when I first started teaching and working with students, and I would tell them that a blue star was really hot. They would completely blow their minds, even if they were able to see visually color. So yeah, I mean, I think this speaks to the fact that all of the things that we're doing will inevitably help augment the learning experience of everybody in the room, which is a really important thing that we're doing. Carol, do you want to add anything?
Yeah, I just had a couple of comments. Quickly, one, I would say that since I'm the Hubble Space Telescope project scientist for Outreach, we come from a fairly rigorous, formalized method for doing the news. We're very, I'm sure that Kim has come up against this. It's less so for Outreach, but for our news media, NASA headquarters is very strict about how we described how many words. So in the formalism of the 33 years of Hubble, we have come up with using what is driven by physics, and that is the black body curves of stars does follow from cool to hot, and we have to use that color scheme, and we have stuck to that for things that are dominated by temperature. And then we also assign the wavelength according to that scale. Then when we go to, as Kim had described, emissions from particular elements show up at a particular frequency or wavelength, or however you think about it. And so we tend to use that color. Now that we are processing JWST images, we have to, the color doesn't really translate, but we still use the same color schema. Reddish stuff is cooler and the whitish blue stuff is hotter. And it's just the legend, the way that we do our color schemes. Now, somebody just brought up Judy Schmidt. We also have experimented both with the public and people like Judy, where they can use colors to be more evocative, but less representative of the astrophysics. So our visualization people have to represent the astrophysics first. So that's why we're fairly rigorous with our color schema for our images that appear in color. I'm glad Nick made the comments that he did. I just wanted to point out, and I found it amusing that you had the Whirlpool galaxy, which was in Kelly's opening slide, and the Whirlpool galaxy is a galaxy which has spiral arms that look like you've stirred something with a spoon, and our 3D print, in addition to using intensity to represent what's going on, the light distribution, we actually use a texture scheme, and we use it in all our 3D prints, both for star clusters, and so it's the same texture. It's a rough stipple or lines, and we worked hard with Noreen Grice to come up with that schema to put textures where the color might be, and also where the astrophysics phenomena is going on. So that's another way of getting away from the color thing, but actually representing the astrophysics in the 3D print. And so we're going to translate that into JWST images, which again follow the same color scheme, although they're kind of meaningless in the infrared.
And I could just follow up on one last point on color. I very much appreciate this discussion, everybody's input. I think Dana mentioned in the chat that upsetting someone's familiar experience is not a bad thing. Yeah, we actually have done research on color perception in the image. And because Chandra is looking at this high energy material, right, a lot of this stuff is superheated gas, very hot gas everywhere. And when we're trying to describe that, do we use red or do we use blue when we're visualizing that data? And so we actually did a survey to kind of question that with people. And though, you know, nobody says to their kid, don't touch that stove, it's blue hot, right? We have this idea of red being heat in there. You can use those alternative colors, those blues, purples, whatever, as long as you're describing them. That was pretty much the key takeaway, that yes, red as the heat color is definitely culturally significant, and that does give the immediate impression. And if you're creating an image that will not have text to describe it, maybe color is more important. But if you do have layers of discussion around that image, and you need to choose blue for whatever reason, as long as you're describing what you're doing and why, that was the key thing. So it's not that we can't ever use the different colors, but just being very, very clear about what we're using and why. That was kind of the key takeaway from the research. So if anyone wants those papers, I can pop them in the chat later.
JJ here, if I could just chime in on this point, and it ties back to a few things that people have said here and going on in the chat. I think a lot of this comes down to making sure you're clear at the beginning of any presentation, any visual description, anything. If you're clear as to what your perspective is and how you're moving forward, you can do a lot. You can be quite artistic. You can be downright poetic if you're clear that that's what you're doing. If you're doing a sonification, you know, someone in the chat mentioned, might this not confuse people to think that there's a microphone in space? And it might, if you're not clear at the opening that this is how this has been achieved, and this sound represents this, and this instrument represents that. Even with the visuals, like someone mentioned describing something as a ring. Well, but what if that ring is on its side and then it looks like a line, not a ring, and in your description, you know, locks it into place in that person's mind? And that could very well be true. One of the reasons, or one of the things we do to make sure that doesn't become a problem, is by using language like here, or in this image, that the ring looks like this, yada yada. So there are different ways to ensure that your audience understands all of these things. You just have to be absolutely clear at the outset. This is what we're presenting, and this is how we're moving forward. And then you're, I think, as everyone here has you know, illustrated with great examples, the audience will go with you. The audience will travel with you on that storytelling journey, as long as you're clear how you're proceeding. End of thought.
So I want to check in and see if we want to take another break. We had one scheduled and we're running a tiny bit behind time, but if we want to keep on with this discussion, we can do that too. So Kim, if you have opinions or thoughts.
I'm happy to skip the break. I feel like that just flew right by, but
okay, so great. So Yeah, I will leave it up to, I think, JJ and Chris were going to lead us through some examples of how we might create image descriptions, if you want to go with that.
Absolutely. So this is JJ speaking. I think we've got an image here. What we thought we might do is kind of just as a group compose an image description together. So Kim's going to throw up an image here. And what we can do is we can use the chat function if people want to post ideas in the chat, or raise your hand, or just unmute and throw out ideas that way, whatever makes you comfortable, however you're going to be comfortable participating in this. So yeah, we're not gonna compose a 4-paragraph super description of this, but we thought we would describe this image bit by bit. And my apologies to those description users who are in the audience. This is the one time we're not going to describe the image that we're putting on screen right off the bat, because that would defeat the purpose of the exercise. So what the goal is for those of us who are on the call who are sighted, our goal is to make sure that this image is described for the people who are on the call and are not taking this image in visually. So what happens when we write a description at Chandra? The very first thing that happens is Kim sends us the most up-to-date press release possible. So the closest to finished press release that she's got. And that gives us, us being Christine and I, the basic science, so that we understand the science behind the image. And so what we've done with this image is just posted a few key points about the image. Normally we would get a few paragraphs, a few pages of press release. Here we have a few points. So the image that we've got here, which is of VV340, this is an example of colliding galaxies seen in the early stages of their interaction. There is an edge-on galaxy near the top and a face-on galaxy near the bottom. Okay, so that's the basic science behind this image. So we want to make sure that that is woven into the description that we all create together. So remembering the architecture of a description, the very first thing we need to do is come up with an overview. So my question to the group is, what are the key things that we need to make sure are in the overview statement? What are the key ideas about the visuals and the key ideas about the science that we need to make sure are in the overview? And again, feel free to throw ideas into the chat. Feel free to raise your hand or just unmute if you'd like. We can all put this together. So what are some of the key things that we need to incorporate into our overview in terms of the visuals? Visually, what's going on here? Amelia?
Yeah, so I think like two ideas that I think would be important to convey here is like we have this idea of a static universe, right? And this picture is showing interacting objects. So it would be very important to say that there is a dynamic thing coming here. And the other thing is also that these are not points, but it is like a highly structured, different kinds of objects that are very highly structured, what we are seeing. Also because of the context of what one thinks of astronomy.
That's
so,
right.
I mean, it's both visual and science. That's
right. So I think you're absolutely right. From the scientific standpoint, we need to make sure that the fact that these objects are interacting, right, is very important, and that they are structured. Lonnie mentions the background of the image. Sure. So what is that? That's one of the elements. I would suggest that there are three key visual elements: the background, and then the galaxy on the top and the galaxy on the bottom. What other visual things do we want to make sure when we're talking about the galaxy that's on top and the galaxy on the bottom? How do we want to make sure they're differentiated? So, okay, we're getting some in the chat here. The square dimension. Yeah, the square dimension of the image. Absolutely. If you want to define the image, absolutely. The objects of interest in the middle of the square. Oh, this is an interesting. Imagine a nose and lips. The nose and the is the edge-on galaxy on top. The lips are a face-on galaxy. Another one, like an exclamation point. Yeah, that was the first thing that popped to mind for me as well. Like an exclamation point, the line above the dot, right? That's a great way for visually to enter into this image. So in your overview, we've got a few things. We're going to mention that this is an image of two galaxies interacting with one another, right? That the galaxy on top is edge on. That's a really important, that's important to understanding the science and understanding why these two spiral galaxies, one looks like a line, so that's what edge on looks like. As Lonnie says in the chat, what does edge on even look like? So that's absolutely important. The edge on of a spiral galaxy looks more or less like a line. And the face on galaxy looks like a spiral. And someone mentioned before, like the result of a spoon stirring coffee. I really like that analogy. I'm not sure that that's an analogy that's going to work for everyone. Chris, what did that analogy resonate with you? I loved it.
I do like it. My understanding of it is more intellectual than experiential, but that's because I grew up without any sight at all. But I still, it does appeal to me.
Great. Yeah. Dana mentions pizza. That's another good one. Face on like pizza, like sauce being swirled onto onto a pizza pie. That's a good one. Okay. So our basic overview, I think we've got an idea of, right? We want to make sure that we mention there are two galaxies, head on over face on, resembling an exclamation point. I would put that right in the top of my description, because I think that makes it so very clear. And so that's our overview. Now we're going to organize and elaborate. So what are the things that we want to how do we want to organize this? Do we want to go image by element by element? So top galaxy, bottom galaxy, a background? Do we want to go, what are some other ways we could organize this? Anyone have any ideas as to the different ways to organize your description of these two galaxies? So we've got, looks like Dana, I think people are seeing Jaco as me, Dana. At any rate, image of two galaxies interacting with one another amongst a background sprinkled with distant galaxies. Fantastic opening. That's a great opening sentence. That's really good. So how are some ways that we can organize? We can break down a description we can talk about what the upper edge-on galaxy looks like. We can talk and then elaborate on what? We can elaborate on the line, maybe the colors, maybe the angle. And how about the bottom galaxy? When we're talking about, so the edge on appears more purple than the spiral. That's a great point. And that purple, really making sure that how luminous that purple is. We're going to want to talk about that at some point, right? Should we mention the bright and nearby star in between them at the end? That's a great point, especially since we've mentioned that they're interacting. That's an excellent detail. Let's save that. Let's put a little pin in that. So when we're doing our details later, we can talk about that little star. The difference in texture, Nick says. The face-on has more detail. The edge-on looks much smoother. That's a really interesting textural detail. And texture is important to talk about in these descriptions as well. Even though this is a visual and not a tactile rendering, tactile words, tactile description is really helpful for people who are taking in this information in different ways. Do we know if the star is on the same plane as the two colliding galaxies? That would be the kind of question I would always ask Kim, because I certainly don't have any knowledge about such things.
It's much closer, yeah.
There you go. Chris, did I hear you unmuting there?
Oh, I was just about to give a double thumbs up to the textural reference when I was talking earlier about the example of drawing on your hand and stuff, and embodied ways of writing description, that's exactly the kind of thing I have in mind, because you know for sure a blind person is going to be extra sensitized to texture. So that any ways that you can incorporate that into your description writing is going to be excellently received.
Yeah,
Right on.
and I love the comment from Rashawn about someone has blown purple dust into the upper galaxy. I feel like that's really quite lovely.
That's lovely.
Mm-hmm.
So evocative, right? That kind of language really
Yeah.
brings this to life. It turns it from
Yes.
being a dry caption into something that inspires awe, like Kelly said right at the beginning. Okay, so now let's move into those details. Again, there's lots we can break down. When we're organizing and elaborating, there's lots to talk about. We're adding those details, that little star or very bright star. And again, talking when you're mentioning that star, you can add the science that is closer than the two galaxies. You can also describe, don't just mention that it's a star. You can describe what it looks like, describe the diffraction spikes, describe the clean color of it relative to some of the other colors in the image. Merging, that's a great word. Again, that would be the kind of the phrasing that we would go back and forth with. I might write a draft of, Chris might say, I'm not sure that works for me, I don't quite understand. And Kim might come in and say, that doesn't describe the science. So this is where making sure that your team that's writing this description has a variety of skills and experiences, and then you can create a description that is accurate and evocative as well. The galaxy appear ready to embrace each other. So there you go, more poetry. we got poets on the call. I love that.
I'm loving this. This is great.
Fantastic.
Yeah, I really love
So
that one.
is
That
this
was
helpful
great.
for everyone? Does this give folks an idea of how one might go about composing these descriptions? Or Shannon, thank you. Yeah, fantastic. Oh, great. I'm glad this has been helpful.
Wonderful. Do we want to stop there and move on to the next segment, Kelly?
Yeah, that sounds great.
Okay, good. I have not been paying attention to time at all, so and I tend to be very bad at timekeeping.
We are running out of time, but I think this has been really valuable. So I didn't want to stop it from where it was going.
I agree.
Do you want to lead a little conversation about image translations?
Yeah, I would love to do that. Let me just bring up my screen one more time. I think so. One of the goals that I've had for this project, I'm going to pop into chat a Google Doc that should be open to everybody. And not everybody has access to Google Doc. If you don't, please feel free to let me know. Hold on, let me just share my screen again. But one of the things that I was really hoping to be able to get as additional inputs from you all is the ability to take some of these visual descriptions and to translate them into other languages. I think we were all blown away by how popular the first James Webb Space Telescope images were, with their alt texts actually getting a feature. And I think it was like the Washington Post, which I had never seen that before. And we've been using them heavily for a while for Chandra, and have really seen from our users writing into us and whatnot how important they are as well. So one of the goals that we have is to start translating them into other languages. And so in this Google Doc, we have a selection of some of the visual descriptions that are of our more popular images. And what we're looking for is suggestions on sharing these out to wider audiences to do the translations. And if anyone here speaks additional languages and would like to jump in and actually do some of those translations, that's a discussion we'd like to have. But as we've talked about a little bit before already during this conversation, is that not everything is going to be a one-to-one translation, right? There are going to be cultural references in some of these existing image descriptions that won't make sense when they're translated, perfectly into another language. Just like translating ones and zeros into an image is a process of translation where the translator is making choices. It's the same thing with language. If you're translating from Mandarin to French, you're going to have to make choices, quite a bit of choices in that process of translation. So again, if folks are in this document, it looks like a bunch of you are. If you have additional languages at your disposal and you would like to take a spin to do a translation of these, great. But I would love to hear feedback on the process of language translations itself. It looks like we have a raised hand, Roshan.
Thank you, Dr. Kim. So I think you partially addressed my point, which I was about to make. This was about cultural relevancy in translations. And I think that's, I completely agree with you. That is going to be one important challenge that one needs to overcome. So in my part of the world, I mean, where I live in Pakistan, the language that's spoken most is Urdu. And in Urdu, I mean, words like embrace, or perhaps as we're seeing right now on screen, I mean, if I talk about red layers, so perhaps I would need to put in a much more cultural reference, perhaps the layers of an onion, because onion's a popular vegetable here. So, you know, I mean, I think that's an important challenge that we might need to overcome when translating into other languages.
Right, I completely agree. And I guess I would love to start with a process of, you know, if any folks would like to actually try translating them and just kind of see what we get, and we do some user reviews to see if they work and all of that. Yeah, I would love additional input onto this process, because I think it's really important to be able to take the work that's already done and try to extrapolate it out to additional people as well. So yeah, anybody else have thoughts on language translations and the possibility of doing this kind of extension?
Gosh, it's Christine speaking. I'd love to read the back translations. Like if something was translated into Urdu and then back into English just for cultural interest, I'd be so fascinated to know what other languages and other cultures do when describing this stuff. That would be fascinating to me.
Me too. I love language, so I feel like that would be
Yes.
really, really cool. Yeah.
Yes.
And I'm not looking at the chat. So let me go agree. Oh, you got an agreement from Sarah. Awesome. And that's another great example of alt text adding value. Yeah, exactly. Wonderful. All right. So yeah, I would, as I mentioned, really love the input. So it looks like there's a question: how, where can we share translations in our local languages with the OAO? Should it be in the same Google Doc? So I personally would love to have the ability to track this other material so that we can use it, because I do get requests for content in other languages. We work with partners across multiple languages. We'll sometimes put out materials in those other languages. So yeah, if you could actually put it into this Google Doc for an exchange sort of knowledge, I think that would be really helpful. And I'll be able to see who's putting in the translation. So I have any questions, I can get back to them as well. But Kelly, I think I would also love to hear from you as to any potential interest from the OAO on helping the process of translations. And also, I believe we were supposed to have someone on from the United Nations Office of Outer Space Affairs. I don't know if she made it or not, Singy. But if either of you would like to talk about that, I'd love to hear it.
Yes, absolutely. So this is Kelly. So I just want to echo this conversation around how deeply contextual language is. Language is deeply rooted in people and place and understanding and a mutual understanding of culture. So any translation that happens it would not make sense to just be one-to-one. So I think this is a really important process that we're going through. I will say that the OAO had at one point the Astronomy Translation Network that we unfortunately had to stop running because we just don't have the people power to run it. It wound up being incredibly popular and just got a little bit more than what we could handle as a small team. However, we are very interested still in translations and making material that is typically produced in English and making it available to people in other places and other cultures. So one of the projects that I've been working on is making JWST infographics, translating those infographics into other non-English languages. And then kind of tagging on as a part of that, also these image descriptions. So I'm collecting people and languages and email addresses in a Google form, which I can put in the chat, that you can fill out if you'd like to be a part of this project that we're working on. If you do happen to speak other languages. So I'll put that there. If you are interested in doing this but don't have access to Google, also just reach out and let me know. You have my email address. But the idea is to make it, provide the framework to create infographics in other non-English languages, and also to do these image descriptions as well. So we're combining the two projects together, at least in my mind at the OAO. So thank you so much for this opportunity, Kim.
There's a couple good questions and comments in the chat. But do we have time to just go through those really quick, or do we need to move on?
Absolutely. We have we have another 20 minutes before the
Okay.
scheduled end time. So however you want to use that time, it's up to you.
Perfect. All right, so Sarah writes that NASA has strong networks of citizen scientists from countries other than the US. These talented, dedicated individuals have strong astronomical knowledge and might be excellent consultants, drafters of all text translations. And she works with Dr. Mark Kushner, who I know as well. And I think that's a really good point. There are solar system ambassadors. There are, as I mentioned, the United Nations Office of Outer Space Affairs also runs like a pretty robust network of translators, volunteer translators as well. So it'd be great to dip into that. But then there's another question who's labeled KD, but I'm pretty sure it's not Kelly. Is alt text or descriptive text something that can be reused for public outreach? As you know, it can be difficult to reinvent the text for each poster, post, exhibit, item, etc. I assume it's the same copyright rules as all published work, but not sure how encouraged it is to recycle with proper credit. I can say that all of the NASA missions that we've been discussing today, the NASA does not claim copyright, so all of the text and the images can absolutely be used for public outreach events. And typically we do, when we're providing materials in another language, we do typically provide a credit to the translation process as well. But yeah, that material is available as kind of an open source resource for you to be able to use for your own events. And I will say again, just to reiterate, we've found the visual descriptions have been very helpful for users of all experiences, all ages, all levels of astronomy knowledge, etc. That it's like having a little astronomer guide next to you, right? That can kind of point out the interesting things to think about, to note, to pay attention to. And so I do believe that these visual descriptions could be quite helpful in your public outreach events that you might be doing. Can alt text be assigned a Creative Commons license? So I can't assign a Creative Commons license to anything I do because as government funded, my material is not copyright claimed. So I can't assign that, but I know ESA, they can and do assign Creative Commons licenses to their work. So that would make it very clear. If you look on like the various NASA websites, you'll see pages that actually discuss that, yes, this material is not being copyright claimed and it can be used for public use. So hopefully that answers your question. Let's see, another KB, I'm not sure which KB this one is, mentions that at ESA we translate a lot of our stuff in our member state languages, but I don't think we have experience yet specifically translating image descriptions. So I'd be very curious, whichever KB you are, if you do try doing that and how it works out, because this is something that is a little bit new. We have some existing projects that we've had volunteers do language translations on before, and it has gone very, very, very well. It's been a pretty smooth process and we've absolutely enjoyed working with them. So I am hopeful that this will be another extension of this. There's another question. How do you best deal with text on images? For example, an infographic consisting out of 5 steps where each step has a short sentence and an image. Sorry, that was me, Dana. So do you mean, how do we label that in the image description? Maybe JJ, if you want to talk a little bit about how we've done that. Which we have had to do that, yes.
Yes, absolutely. So if you're doing a full image description, any text that's in the infographic should be included in your description. And again, just making sure you're clear, this star labeled so-and-so in, in the infographic reads, and then you can just write it out. If you're doing an alt, you can summarize to say that it includes textual information, or you can use phrases like it's an annotated image or something like that to make sure that the text is referred to, even if you don't have the time in that particular description to include all of the text. But generally speaking, if you are writing a full description, any text that's part of the image or infographic should be included. And while I'm here, I just thought I'd add a little bit. A couple of times we've referenced, Kim, you've referenced, having a little astronomer beside you, guiding you along as you read these descriptions. I think that's a wonderful and very helpful idea, especially when you're starting to write these descriptions. One of the things I do as part of my work as a describer is I work with museums and galleries when they create tactile reproductions. And as Nick was saying earlier, this really resonated with me, Nick. This idea of making sure that you lay out your order, right? You're guiding people through. And what we do in a museum context when we create tactile reproductions is we make sure that we also include a tactile tour, an audio tour, because if you just hand someone a three-dimensional model and give it to them to explore and they don't have any contextual information, it doesn't make any sense. So we create these tactile tours where I will say, starting with your hand in the upper left-hand corner, move along to the middle and then slide your fingertips down 3 inches. Here you'll find a raised line. That raised line represents, and then you go forward from there and you literally guide someone's hand through the description, mentioning texture, the texture that feels like polished concrete is this, textural height represents this. And that idea of guiding someone through the description, I find, is really helpful when you're starting to write your description. You are literally guiding someone through their interpretation of this image. And that might go from right to left. That might go from center out. However it works, the idea that you're guiding someone through this description and translation. When you're translating, some of that might shift around as well. Yeah, just an idea I thought I'd drop in. End of thought.
Yeah, that is great. And I think the next question actually would be great if you and Christine want to take a whack at that too. I've run out of almond milk and I'm starting to lose my voice again, but it says, are the measurements of astronomical units expressed? If you cannot imagine, I'm thinking the scale. So this is from Carla. So I guess that's a question about how do we talk about the scale and magnitude of some of these things. And I will just add that it is very challenging to talk about scale in general, because no human has a true access point to the magnitude, the size, the distance, the overall scale of these objects, because they're so astronomically large, I guess, pun intended. But JJ and Christine, do you want to talk a little bit about dealing with scale?
The first thing that comes to my mind is I go back to short sentences and a lot of commas. And the reason that my mind goes there first is that's not, so trying to embrace the scale is not actually a description issue. It's a cognitive imagination, science educator issue. And so the reason that I come back to the punctuation is that the scale is so hard. I'm glad you said that, Kim, because you work with this stuff all the time. And if even you have trouble with the scale, I feel, more enabled. I feel more enabled to say it's hard to grasp this. And so the more concise you make your writing, the easier, well, not easier, but it helps with the cognitive load. Long sentences are hard to parse. If there's not a lot of pauses indicated by punctuation, your mind has trouble with slippery concepts. And so when you keep your sentences short with lots of periods and commas, it gives the brain a little minute rest, a tiny little rest within which to try to process the magnitude of the concepts being discussed. And it's not to say that the simple, half-second pause that your screen reader gives you when you put a period there, it's not to say, oh, then you'll understand the scale of the universe, but it's one small way that we can package information that gives just the tiniest little pause to help our minds try to grasp something so huge.
Absolutely. And similarly, I will often leave a description of either distance or often what Kim provides to us is how far away this object is from us. That is often a distance that we get to include. And to Chris's point, what we'll often do is that'll be the last point that is made, because it is such a profound idea that all of this stuff that we've just been talking about that is occupying your screen, all of this stuff that appears in an image that is 5 inches by 5 inches is happening X number of light years from where we are right now. And that point is hard enough to imagine. It's profound enough that it's the whammy at the end of the end of the description. That's a nice storytelling note to end on.
It's true. If you lead with that, with that, the rest of the description is just like it's just lost.
Jelly.
But don't lead with that. That's a take. That's the only takeaway. Don't lead with how far away it is or how big that picture actually is, because your mind, the reader's mind, will just not be able to take in anything else after that.
That's right.
Wonderful. And there's another question from Cesare, question for Kim, I think. Once you have translated versions of the visual descriptions, how do you plan to publish it? Are there translated versions on the Chandra website? And that's a great question too. And part of my answer is, depending on what the response is that we get, will dictate what sort of system that we'll need to create in order to serve these. Ideally, the folks that are doing these descriptions are also going to take them back to their community for use with their outreach events, their community events, and communications and all of that. But yes, as we have done with other materials that we've done group translations like this, we have served them up on the Chandra site. And for example, we have a project where we've got about, I'd say, a dozen languages translated, and we just serve them up individually on the site for that project. So I imagine we will likely do the same thing. Again, maybe if we only get 2 language translations, it's not as much of an issue to serve it up, but that is the hopeful idea. So. And there's another comment, working on for a project. This is from Rashan again. We've got working for a project by the IAU OAD on making astronomy content for Pakistani children in Urdu. We are collaborating with a local science museum to create an astronomy exhibit. 80% done. Congratulations. And only now am I thinking we should definitely work to incorporate BVI accessibility elements. Yeah, that's okay. It's not too late to start. It is absolutely not too late to start. And I think at this point, you'll have created a lot of the materials that you need to then do the visual descriptions for. Sometimes it is hard to start too soon, because until you have your visuals set up and the content that you want to say about them, there's not a whole lot you can do. But now that you're well away into the content creation part of it, I think it'd be a perfect time to be able to incorporate those elements. So yeah, kudos to you for that. Iris had to leave, but awesome, thank you. Another folk had to leave. Let's see, Sarah says, great point, Christine. Clear science presented with best educator practices in clear language are essential. Which leads me back to scientists. What resources are available to help scientists do a better job describing the images that represent their research? Sarah, that is a wonderful question. I would say that I have created like a best practices document along with Christine and JJ and Megan and Peter on my team that is open and accessible. And I think at some point it'll be coming out in the Communicating Astronomy journal as well. Kelly can tell me when. I think we're still editing it. So that would be a resource that's publicly available with some very simple, clear best practices that could absolutely be spread through research networks in order to be able to help them think about these things in new ways. Additionally, I would say, workshops like this would be great if they wanted to join as well. So that would be 2 points back from me. Let's see, Sarah would like a link to that resource. I will drop that into chat. Actually, I think Kelly, I gave you that URL if you want to drop that in for me. And then JJ, there's a question for you. Is there a website where we can see your past ongoing projects? It'd be great to see your descriptions and continue learning from them after this workshop is over. Oh, I completely agree. Their podcast Talk Description to me is really excellent. It's where I started. And it's given me a ton of information. And JJ and Christine are both natural teachers and mentors. So I think that being able to go back and listen to some of their existing material is brilliant. So JJ, if you want to pop that into chat, a direct link, I don't have that handy. That would be great.
Yeah, will do. Absolutely.
Awesome.
Thank you. And yeah, and I appreciate that, Roshan. And that's exactly where I'd say starting as well. Of course, I've got a website, which is jjhunt.com. It's so woefully out of date. I'm too busy doing the work to to track the work. But the podcast is a good starting place, I think, because you can jump into whatever topics are of interest to you. If you are interested in the space exploration side, we've got stuff there. If you're interested in weather systems, we've got stuff there. If you want to know how to describe jazz hands, we've got stuff on that too. So Christine and I had all kinds of conversations. So Chris, I'll put that link in the chat if there's anything else you wanted to add to the about what can be found on the Talk Description website.
I'd like to, if anyone goes to troll around on the Talk Description to Me webpage, I recommend the episode on the Northern Lights. And the reason is that it's a beautiful combination of straight up description, but also I requested some editorializing because the Northern Lights are known to be so beautiful and so mythologized and so iconic that I wanted JJ to be a bit poetic and to talk about his personal experience and feelings. And so, to my point earlier, that sometimes it's great to bring your own personal voice to description. The episode on the Northern Lights was a real treat for both of us, I think. And so I draw your attention specifically to that one.
Awesome. And I would also recommend for folks interested in more of this work too, to check out Nicholas Bond's project. I don't know if we can pop that URL into chat as well, Kelly. I think it's just the tactileuniverse.org. Nick, remind me if that's it or not. But we can Google that and bring it up if not. And then I guess just for the last couple of minutes, Kelly, I wanted to steer it back to you and I guess possibly Cesare as well to talk about any additional incorporation of this type of material into the outreach activities that folks might be doing. And let you kind of take us to a close.
Yeah, so I think that we've really established that there's a really wide array of things that we could be doing with making our images more accessible, making our astronomy more accessible. And what I'd like to do is just plant the seed in your mind of thinking about ways that you can incorporate this into your work, whether that's a project that you're doing with a local museum or something that you're just trying to do in your own practice as part of your work for your institution, or even your own personal posting online. And just think about how you can incorporate these things and all of these resources into the work that you do. And we're going to follow up with you maybe in a few weeks to just figure out or see how this workshop impacted your review and what you might have learned from it. So take a look at all the resources, digest it, and then think about ways that you might be able to incorporate this into your work. But do keep an eye out for that. And just so you know, if you didn't hear at the very beginning, we did record this session and I will be making that recording available to everyone. So you'll be able to hear this really rich discussion that we've had today. That is it for our side. We did a great job of running through all those questions so fast. If there's any other questions that people have, I'm very happy to stick around for another few minutes if our friends and colleagues here would like to do so as well. Completely up to you. But yeah, so thank you all for being here. Thank you for being a part of this, and thank you to all of to JJ and Chris and Kim, Nick, and Cheryl for being here as well.